In this video, we're going to talk about scaling ratios or scaling factors. So I'm going to rate them with a colon here. If the scale ratio is 1 centimeter to 100 kilometers on the ground, then this is 1 times 10 to the negative second meters to 100 times 10 to the third meters. So I'm going to multiply both sides by a factor of 10 to the second, be 1 to 100 times 10 to the fifth. The meters are going to cancel out, and this is going to be 1 to 10 to the seventh is going to be our scaling factor. So 1 unit on the map is equal to 10 to the seventh of those units, or 1, 2, 3, 4, 5, 6, 7. 1 to 10 million. That's our scaling factor on the map, from the map to the ground. So if there's 1 inch on the map, represents 10 miles on the ground, then we're going to have to do some conversions here to get from miles to inches to figure out what the scaling factor is. So each mile is, just a second. All right, so we need 1 inch on this side, 10 miles times 1 mile is 1,760 yards, times each yard is going to be 36 inches. So let's figure that out on the right-hand side. 10 times 1760 times 36 is going to be 1 inch on the map is 633,600 inches. So my scaling factor is like so. So 1 unit on the map is worth 633,600 of them on the ground. Find the scaling ratio for a map for which 3 centimeters is equivalent to 6/10 of a kilometer on the ground. You can see that metric is way easier. So the meters are going to cancel here, and I'm going to make this 3 is to 0.6 times 10 to the fifth, and 1 is to 0.2 times 10 to the fifth. So 1 to 2 times 10 to the fourth, if I wanted in scientific notation, or 1 to 20,000 as my scaling factor. The scale ratio on the map, that's 6 inches, represents 7 miles on the ground. So again, we're going to have to convert miles to inches to get our scaling factor. To do that, we're going to have to convert miles to yards first. So we're going to use that same conversion factor that we used just a second ago. So 6 inches, 7 miles. times 1 mile is 1760 yards times 1 yard is 36 inches. This is going to cancel out over here, and inches are going to cancel out with inches, yards with yards, miles with miles. This be 1 to 7 times 1760 times 6. 7 times 1760 times 6 is 1 to 73,920. So 1 unit on the map is worth 73,920 of that same unit on the ground. And the scale ratio for a map if 4 centimeters represents 10 kilometers. So 4 times 10 to the negative second meters, 10 times 10 to the third meters. Meters will cancel. 4 to 10 times 10 to the fifth. So this is going to be, let's just make this 1 times 10 to the sixth here to make my life easier. 1 to 1/4, 10 to the sixth. It's 1 to 2, 5, 1, 2, 3, 4. So 1 to 250,000 is my scaling unit, scaling factor. Suppose you are constructing a scale model for the solar system using the scale ratio of 1 to 10 billion. Right. And your scale model, what will be the diameter of Jupiter in meters if Jupiter is 143,000 kilometers. I'm going to divide that by that 1 kilometer. Yeah, so we'll keep the units the same here. And we'll say that this is going to be 1.43 times 10 to the, there's already a 10 to the third hidden there in meters. And then 1, 2, 3 is 6. And 1, 2 is 8. This is going to be divide by 10 to the 10th, 1.43 times 10 to the negative second meters, 1.43 centimeters is what the diameter of Jupiter in your scale model should be. Make sure that's right. That's correct. They answered it in meters, so they went to here. They answered it like so, which is fine. It's the same thing. All right. Now let's look at number 49 here. Suppose you're constructing a scale model of the solar system with 1 to 100 billion. scale model what would be the distance from Neptune to the sun in meters. Oh, it says in meters. That's why they answered in meters. Okay. So we're going to change everything to meters. So scaling factor is 1 to 100 billion again. So 1 meter is going to be the same as that. So now we want to ask what is 1,427 million kilometers. So million is 10 to the 6th. 1,000 for kilo meters. And we're going to divide that by 100 times 10 to the 9th, our scaling factor. And 10 to the 9th is going to cancel out with that. And we're going to divide by 100, so this can be 14.27 meters. I just fixed my numbers. I wrote some numbers out of problem 50 for problem 49. So it was 4,497 times 10 to the 6th times 10 to the 3rd, which is times 10 to the 9th meters, divided by 100 times 10 to the 9th. For the scaling factor, the 10 to the 9ths are going to go away. 4,497 divided by 100 is 44.97. Make sure you get the right numbers there. And now we're on to number 50. Suppose you're constructing the scale model of the solar system, the ratio of 1 to 200 billion. 200 billion is that. Scale model of distance from Saturn to the sun in meters when its distance is 27 million kilometers. And we want the distance in meters. This 10 to the 9th is going to cancel with that. So this is going to be 7, 5 hundredths is going to be 7.135 meters in the scale model. And for the last one, the distance from Earth to the sun is about 1.5 times 10 to the 8th kilometers. The distance from the Earth to the moon, about 3.8 times 10 to the 5th kilometers. Scale model of the solar system is constructed so that the distance from the Earth to the sun is 100 meters. So 100 meters to 1.5 times 10 to the 8th kilometers. Right? Then we're going to have, this is 100 meters to 1.5 times 10 to the 11th meters here. And we get 1 to 1.5 times 10 to the 9th for our scaling factor. And we want to know then what will be the distance from the Earth to the moon, 3.8 times 10 to the 5th kilometers. divided by 1.5 times 10 to the 9th. So this is going to be times 10 to the negative first, 3.8 divided by 1.5. It's 2.53 repeating times 10 to the negative first. Meters is going to be 0.253 repeating meters, or we could call that 25 1/3 centimeters, because it doesn't tell us how to answer it, so we can answer it exactly that way. All right. That's it for this video, and we'll come back next time and talk about our last little section here in this section of the textbook.